Welcome back to Stationeers, and I make a brand new video about an entirely new game system, and the day after it gets re-implemented. That's the beta for you. So we've got an entirely new machine to build now called an IC housing, and we'll get that going. And we're also going to need an integrated circuit because this is the renamed version of programmable chips. If you did have the version I had and then reload the game, well, some bad things could have happened to you. Between various things, it killed me once just reloading the game, but when it actually got a bit more stable, reloading the game gave me just an empty space where my chip is. So the horizontal axis here is working perfectly fine. It's the vertical one isn't because it needs a program. Okay, so in here we've got the IC editor now. It's called that did automatically change over. It's just the fact that previously, the chip itself was a maths processor chip, and now it isn't. Now it's two separate pieces because you now are able to save the program just by, as the IC housing, save the program, let's drop this over here, by just moving the chip itself, as it comes in two separate pieces. So IC housing is one piece, and the other piece is integrated circuit. That needs some electrum, and the cost has been increased. So now you're going to need electrum, steel, and solder solder and steel is for the housing. Electrum. Oh, you're also going to need solder and steel for the circuit as well. Okay, so I'm going to have to make more steel soon. I think that's what the last of my last batch of steel, and the steel thing is turned off, so that might cause a bit of a delay when I do it. So let's do this and see whether I can get it up and running or not. It may have to be next episode, we'll see. Are you nearly finished? 50%. Okay, let's go and put this down while that's done, because the way the program works has changed significantly as well. And we've now got lots of different inputs and outputs. So let's just pop that down. And you'll see now there are different screws. So there is D0 through D5. Or 00. I think that's D0, yeah. Circuit housing, and we can turn the circuit housing on, etc. So we're going to use that as a programmable sort of housing, much like you would in the real world. And here's our cute little integrated circuits, just like you're used to if you see motherboards, and pretty much any circuit these days has integrated circuits. In this case, however, they're programmable, which all integrated circuits normally aren't. But let's put that in place. Oh, I do quite like that. Recatech? Not sure who Recatech is. Maybe one of the developers, but in any case, IC10. So we are going to then be able to select the IC housing. I think we can just rename that. So let's just set this one to say solar control. Okay. And put that back away. Solar control. Okay. Turn that off and back on again. There we go. All right, so import from that, there's nothing in it. Now if we press edit, we get an entirely new editor, or rather a lot of changes have been made to it. So you see, one, it looks good, but two, there is a library that we can create new source code in. So we can save that in there, or may well do that now and clear it, copy and paste, and you'll see there are line numbers. So much better and pretty good. So let's just re-import that program from the last episode. And after looking at the reference code, I'm probably just going to start again because so much of it's changed. The simple bits are the same, but I just want to get everything sort of nice and clear in your head, ideally. So on the circuit housing, I've set the first screw to daylight sensor vertical, the second one to daylight sensor horizontal, the rest are unset. Okay, they can apparently be used by both input and output, so that will be quite good. And then we're over to the circuit editor. So let's get started. And we're going to write something that loops, but let's just move this down a little bit. So we can now label some lines or locations. So if we have something like this, this means we can jump back to start later. No matter where the line number is, we don't have to worry about line numbers there. So I can just say, for example, well, in fact, we'll come back to that later. But the idea is eventually we'll have yield, and then we can jump back to the start like this. Okay, so that would just loop through those 3 lines. Above them, we're just going to set some labels up. So we have label D0, let's just call that V angle, and label D1 H angle. So we may not use H angle, but we may as well have it in the program anyway, because we're already getting the exact output that we want. We may just be able to save a logic reader perhaps by doing this, but in any case, we've got both of those. And then now we have many more internal registers. We have like 16 registers. We had like 5 before, or 6 or something like that. So we can also label those. And we don't have to do too much in this particular program, but we use the alias command for that, and we can call, I don't know, this... what are we going to call it, really? V-corrected. V-corrected. And we can take that to R0. So we're just going to be continually using R0 in this one. And that's pretty much it for labels, I think. So we can then, we're able to load values into that, I think. So if we just load, let's just get another new line. So load solar angle. Is it going to be solar angle? What do we actually call it? Sorry, V-corrected is what we're going to call it. Yeah, V-corrected. And we're going to load that with the vertical angle, solar angle from D0. So remember, D0 is set to the actual sensor, not the logic reader. So we need to actually specify what setting we actually want. We want solar angle. I think that's what it's called. This won't work if that's not the correct thing anyway. But we should be able to load that, hopefully, into V-corrected, and that should be fine. So then we can probably do some of the sums. What was the sums we needed to do? It was subtract and store in V-corrected. 75 minus V-corrected, I think. And then it was divide and store in V-corrected. V-corrected and 1.5, I think. Okay, and we need to then think about where to put this start line. So let me just delete it from here. And we want to assess all of this, don't we? The labels and aliases are fine, but we're actually loading in from here. So we need to start around about here, like that. Okay, all of this stuff is just preparatory stuff. We don't need to loop through that again because it's only need to be set once. Okay, it looks like the line jump syntax has been changed, or at least it's been removed maybe. So this now works. I've added a couple more labels, D3 and D4, in that we should be able to output to those as well, so they can be used as outputs, just to demonstrate it. Not that we need it for this one, not that we need horizontal angle. Really all you actually need is this one for this particular program, but just as an example, so you can expand it yourself, you get the idea. So we've got alias V-corrected R0, so we're going to load V-corrected with D0 solar angle, subtract it from 75, divided by 1.5. Now we need to output something. So the actual output we're going to be using is the base device itself. So to do that, we want to say store to the base device, DB, device base, I guess, that way around. We want to store, which way around is it? The setting, I think, of V-corrected. Am I remembering this correctly? You never quite know. Okay, that looks right. And we can also do the same thing for those other labels. So we can store, let's just add an extra line, store, you could use D3 or you could use V-corrected angle. The setting, and then we want V-corrected again. And we haven't really read in, horizontal corrected, but just to illustrate the idea, let's just use R1. So let's just add an alias for horizontal corrected. Not that it needs it, you know, there's no actual correction going on here, but you get the idea, just so you can use this. And H corrected, And then we just say D1, which is the second screw we set, and solar angle for that as well. So we can read everything in, do all the calculations on one of them, and then we can then store H corrected angle, setting H corrected. So we're just outputting that internal variable. And then we need to jump to somewhere else because we've added all of this in. So we need to jump to line 8 now. So we're loading stuff in continually. So jump to line 8. And that should be it complete. And now we'll let's see if we can export that. Yeah, there's something wrong with it. I've probably got the syntax wrong on one of them. So there's V corrected, there's H corrected, etc. And here on this side, you'll see there's V angle and H angle. That comes from the label side of things. I'll just figure out what's actually wrong here and then we'll come back. And it was probably rather obvious for all of you people watching, just to see what I actually need to do. I just need to set up a couple of memory chips and I've forgotten to do that. So we're just printing off a couple now, just so I don't have to save anything, or really tear anything else down. So let's get these memory chips installed. And then we should be able to get things going. So let's first of all, I've torn up one of the logic readers. We don't need one logic reader anymore. This is all actually now working again, by the way, because I just deleted those lines. And we just need to be able to address these memory chips. So why don't we put them just as a convenient location? Why don't we put them here? And that will make a nice nice block here. So this one is the... Which one is it? The horizontal. So let's just call that, that was my rename tool. H angle memory. And that makes this one V angle memory. Turn this back off. And then we just need to just switch out these with four-way junctions. There we go. Then we should be able to see these from here. So if I then set this to which way around was it in the code? Let me just edit this and then re-update it with the version that hopefully is going to have problems, but one second. Okay, here's the updated version, just with everything included. So I've got store D3 on the setting, V corrected and H corrected. So we should be able to set D3 to V and just confirm that and export it. It'll probably go, yeah, that'll be a problem. We just need to set that to V memory, V angle memory, wherever that is. And that now works. So we've got V corrected and H corrected. Okay, so V corrected, well, H angle memory, yep, V angle memory. Both of them are updating, which is good, because that means I don't need this logic reader anymore. I will actually need to set it. I'll need to set the batch writer to actually read from the relevant memory, however, but that should be simpler to actually do. I just need to set this to the input, don't I? So it's going to be H angle memory. And I may have to click through a few of these things because... Oh, I've gone one too far. Can I V it back? No, I can't. Okay, one second. And there we go. This one is set to H angle memory. This one is set to V angle memory. Outputting to vertical. Outputting to horizontal. Those four work. It's only 2 powered chips. We can remove those. One further power chip. This is the IC housing, and we just need to make one more change to this in that I don't need to output it to this anymore. So line 14 can go away. And that, what? Let me just... there's still a few bugs with the editor, it seems. Let's just set this to D3, setting V corrected. There we go. Yeah, there are some... the editor's very new, okay? All right. And that is everything. Now, of course, all that we're really doing here for the horizontal is we're just feeding it in and then replacing this as a logic reader, so it's doing that job as well. And because we're using unpowered chips to output to, that again just saves us one more logic reader. If you want to put the logic reader back in, be my guest, there's no problem here. So I'm just going into the library and I'm just going to save this over the solar angle calculator and close that off. And now this program does its job, or should do its job. Now I've corrected it. Export, and now everything should be working. Someone did say I can use min-max to basically make sure that these didn't have this weird behavior at the night time. I'm not too worried about it. That's no problem. All you're really doing is min-maxing the horizontal approach to things, but you can do that as an extra line of code if you wanted to. I will copy this into a can I actually... Sometimes trying to copy this is not the easiest, so I'm just going to use the button to copy all of that, and hopefully that can go into the paste bin. You can see below. I did get word from Rocket saying that the workshop will have support for sharing code. Now, because I'm using this on a personal account rather than my Gradaster account, I may need to rebuy the game if I want to do that. So for the moment, I'm just going to use paste bin on this kind of thing just to sort this out. And we should be done. So everything else we can clean up here. We can get rid of all of these chips now, and we're down to just 3 chips from last episode's record, down to just 3 chips, 3 powered chips that is, and we're pretty good for solar. So I think that is pretty much good. And this is going to be a shorter episode than most because I just wanted to update you on the new behavior of the integrated circuits. We may have a slight change next episode, depending on what gets implemented on top. We may be able to re-add that jump sort of syntax for labels, which would be quite handy on longer programs. It's not much of a problem on this one because you can read off line 8 now rather than having to count from the top, just because this really nice gutter line numbers, which is just pretty standard for a code editor. So hopefully that is good for you. If you like the episode, feel free to like, subscribe and share, and next time we'll come back probably for some more hydroponics with programmable chips, because we now have 6 inputs or outputs we can use, and as long as we output them to logic memory, we can use that for all kinds of different things. And you can literally do D3, for example, as the one of the screws, setting, and then 0 and 1 to get booleans out. And you can use that to trigger lots of different devices, because you'll put those into memory and use a reader somewhere else, just very simply right next to the device, looking at that memory to read it essentially and turn things on and off. One final thing, it would be really good if there was some method to select, and this is probably more of a suggestion again, I have mentioned it before, but if there's some way to just say with a data card, shift right click on this memory unit, shift left click on this screw, and then I wouldn't have to worry about left right with screwdrivers over and over. In fact, even make it an extension to the screwdriver, shift right click, shift left click, and that just makes it so much simpler for setting up large networks with stuff, if we could actually do that. If it's not possible, yeah, no problem, but just a feature suggestion for that. Otherwise, yeah, I'm pretty good here. As always, guys, thanks for watching.